Or okay, we are live.
Okay, welcome to this meeting of the War and Astronomical Society. I'm Bob Tremblay, your first vice president. Um, we'll we'll wait on the president's report. First vice president report is I have lectures up through May. I could start using some lectures in May. Was thinking of doing something today. I those presentations I did where we had a panel of people were pretty popular. I'd like to do a couple more like that. And I was thinking, I don't know if we can do anything on stellarium about that, but I know a lot of people use stellarium. So anyway, um, I could use some more lectures starting in May, and I've got a couple interesting ones. Um, let's go on. Is Riyadh here? Yeah, Riyadh. How about an observatory report?
Yes, hi, thank you. Yeah, we had our last observatory meeting. Basically, it was um, uh, an open house, a virtual open house through Doug Buck's Northern Cross Observatory. We observed a number of objects. He talked to us about how his equipment worked, answered a lot of questions. And then, in addition to that, in the last WASP, he has a report with the images that he also took while we had our observing session. So, um, next open house is going to be. I'm trying to look for the date here. Sorry, on the 26th of this month. Um, I will more than likely not be able to make it, but I think Jeff McLeod is going to be able to do that. So hopefully we'll have a lot of people going out there, and hopefully we'll have good skies. That's all I have. Thank you.
Great, thank you. Adrian, treasury report.
Sure. So there are a couple of action items I haven't quite finished yet, but one is to migrate our funds from our second account for GLAC into GLAC's own treasury account, which is held at Comerica. So that is on to-do list for Friday. Our main funds are holding steady at around $22,000. All checks that I've received for membership, which is now around 104 paid memberships, those checks have been cashed. And if you've sent any checks to our PO box, which we recently re-upped, and that was one of the expenditures that we had to do for this month. If you've sent it since the last couple of weeks, as soon as I get those from Mark, I think you sent me another package, Mark. Those will get added to our account as well, and so those checks will cash. If you ever have any concerns about a check you've written to us, Warren Astronomical Society, and you're not seeing it get cashed, please do send me a message at treasurer@warrenastro.org. You are free to ask me about it as much as you would like. And I'm putting the email in the chat. And really quickly, while I have the floor, I know this is something that our president and maybe Bob, maybe other VPs might address, but we are looking at, again, we are still looking at having a meeting to discuss going back live. But there are a number of members, those of you that may watch this later, that are concerned about whether or not we're going to get back together, considering the state of COVID, which, as we know, we see the relaxing restrictions. We are working on, we are going to discuss it as a board, and we hear your concerns. We know that a lot of you, there are a couple of you that didn't want to come to a virtual meeting anymore, and we will take that into account. We know, our membership, it's the lifeblood of the club. At the same time, we're happy to have David able to join us every meeting, and that's not possible without virtual. So at the very least, we are going to keep a virtual component of these meetings, even if we're doing hybrid. We're all meeting in one room, and a few of you can still join us virtually. So we intend to keep that a part of the meeting. So I wanted to put that out during my report. That's all I have as far as Treasury. And Bob in the chat has posted the newsletter. I will post that to our live stream. And that's it for my report, Bob.
So our GLAC meeting, we were also talking about whether we were going to be doing it live again with probably with again this year. The idea is to go live unless things change. Is that not correct?
Yes.
And
Yeah, planning is kind of gone underway for going live. I think our president John Wallbank seemed pretty intent on saying this time let's figure something out and do it at Island Lake.
that'll be in September. What are the dates on that
Yes.
again? The middle of September?
17th and 18th, I
17th and
believe.
18th.
Yeah.
And there'll be a lot of planets out then. So hopefully, COVID will be for the most part behind us at that time, and there won't be another new variant. But anyway, okay, so yeah, the WASP is up. So Secretary Mark,
Hey, how's everybody doing? Doing all right?
alrighty.
Doing
Okay,
good.
my report.
Good.
First of all, Adrian, tomorrow you'll get your package. I have 2 bank statements from our institution. I do have another membership, and whatever else is in the PO box will be sent to you tomorrow. Okay, so
That's right.
I only have 1 membership so far.
Okay,
that'll
so
be coming your way.
that'll be checked. And hopefully you sent me the that paperwork that we were supposed to
Yes,
fill out for
that's gonna be
John Root.
That's gonna be in there also, okay?
Okay.
You get a nice package right there. Minutes are in the WASP, and as for any type of activity, the library telescope program um, is gonna be launching in Warren. We don't have the set date, but it will be in April. But on March 10th, we did uh, a family event for the NASA at My Library grant that the Warren Library received. We had a total of about 35 families there, or a little over 80 people with kids. And actually, the clouds broke a little bit where we could at least look at the moon. So we're able actually to look at something. And we actually used the library telescopes. So we were doing kind of like a pre-promotion of the program for the Warren patrons. So that was very positive on that. So that's all I have to report.
Alrighty, thank you. I am posting a link to the new Challenger Center that is opening up at St. Clair Community College. I unfortunately was so busy I missed an invitational to a tour of the place a couple of weeks ago, but they're going to be having a grand opening in May. During one of the live meetings several years ago, a gentleman came up to me and asked me, "Are there any NASA facilities I can take my grandchildren to?" And at the time, Ohio, so that's not a good thing. But this is probably the closest thing you're going to have to that. They're going to be doing a lot of different things. It's going to be kid based, and I just can't wait to see what they're doing. And I would seriously like to partner up with them. So let's see, Diane here yet? No, as outreach. Okay, so um uh observing reports.
Talking about outreach yet?
Go. Kevin's not here. Well, yeah, anybody done? Well, let's talk outreach. Has anybody done any outreach events?
Well, I do that.
Yes.
I do that,
Go ahead, kid.
that weekly meeting on Facebook
Wednesdays.
about some stars in the sky. This last week, I did the Guardians, the 2 stars that sit near the north. And also last week, I did the Big Dipper, and of course the Pointer Stars. And each week, I get probably 15 to 30 responses from the things that I post on it. We also did one on the winter circle, which was very cool as well. So I get some real good feedback from that, and just tell everybody that I'm a member of the Warren Club, and where we go from there. So that's an outreach every week. There you go.
Cool.
All
Thanks,
right.
Adrian.
I will jump in. My outreach numbers are stepping up pretty big. 2 days ago, I presented for the Ann Arbor Camera Club, a similar presentation to what I did for our banquet. Basically travelogue, and what I do is I add a few images into the slideshow that the deck of slides as well as the slideshow. I will be doing it again tomorrow for the lowbrows. I will be the presenter, and I'll be sharing the places that I've gone and insight that I've learned from going to different locations, and doing the landscape astrophotography. On the 22nd, I'll be doing the presentation for the Detroit Public Library, and we've got that set up. We're ready to go. And I'll be going to Wyandotte to join Steve Whitty and a couple other people. I forget the name of the radio show, but I will be doing that radio show in the evening, 5:30, talking about my travels. And so those are all of the presentations I've got going in May. And also, like Ken, I've got a gig every week with Explore Scientific, where I share my night sky images with their global star party. And
Can
that's
you
Explore
post a link
Scientific.
to that?
Yes,
Thank
it's
you.
I'll post. You can find Explore Scientific on Facebook, but I'll post the easy way to view it is to just go to their to this URL that I posted in the chat, explorescientific.com/live, and I'll put that into the YouTube live stream as well. So
Hey, thank
that's
you.
it.
Okay, so special interest group. Did Riyadh any double stars? Guys view any double stars?
Unfortunately, not at this time, but of course, once the weather improves and we have some clear skies, I intend to go back to having our list, and hopefully when I can be at the observatory, maybe in a couple of months, we'll go back to observing double stars. And in addition to that, as I mentioned in the last meeting, we have a couple of pieces of equipment that I'm looking at to get for the observatory to improve our ability to do more than observing. Maybe we'll do a little bit of science as well. One of them is the atmospheric dispersion corrector. And the other thing is what's called a star analyzer. Basically, it's a small spectroscope. So hopefully we'll be able to do a lot of work like that in the future. And this will be tried out with the Revolution imager that Adrian donated to us. Thanks to Adrian for that. And later on, hopefully, once we know exactly what we need, we'll also purchase a digital camera for Stargate. So a number of things that are coming up for the future, and will keep us busy, and should be a lot of fun, and should also be able to do a lot of actual science with it, and maybe it's a good thing for the general public as well. Thank you.
I remember several years ago on the March open house, it was shirt sleeve weather. Think we're going to have that?
Hopefully, once again, yes, we will.
Okay. Say any other special interest group? Is our new radio subgroup here?
I got astrophotography.
Yeah.
Everybody's got astrophotography. Once I let you guys go, you're not gonna stop. Actually, I tell so many people about that. It says, you want to see some cool stuff. Every single meeting, these guys just show the coolest stuff, and I'm just sitting here drooling. So go ahead, guys. Go ahead. Let's start astrophotography.
All right.
Do the cool
Let me
stuff.
share something. First of all, happy St. Patrick's Day, everybody. Let's see if I can share this.
Happy St. Patrick's Day.
Can you guys see this?
Yep.
Can you see this picture?
Yes, we do.
Oh, where'd you go?
B33 and IC 434. For those
Well,
that like the
close.
technical name of those.
That's close, Adrian, but no cigar. Anyway, I found a clear night last month here in February up here at Cadillac West, and I was able to image the Horsehead. This is 2.5 hours of integration time. This is technically Barnard 33, and this nebula is NGC 2023.
Okay, I
This is
shortened
2.5
Barnard to
hours.
B.
2.5 hours of integration time. I wanted more, but then the clouds rolled in, so I had to get what I got. This is through my 11-inch SCT with my one-shot color camera. The Horsehead here is about 1,400 light years away. And as far as height, they estimate 3 to 4 light years tall. So think about this, people. The height of this Horsehead is pretty much equivalent to the distance from Earth to our next closest star, Alpha Centauri. So this is pretty huge in the grand scheme of things. These spikes here were coming off the real bright star of Alnitak. Now the Horsehead is located in Orion, right next to the left belt star, Alnitak, and that's what helps brighten this nebula up. I remember we had, and this is very hard to see visually. I remember years ago when we had Star Party up here at Cadillac West, we had the club's 22-inch Dob. And even with the 22-inch, I was using a hydrogen beta filter. It's very, very difficult to see the Horsehead, but you could make it out. So it's very difficult to take your telescope out and try to see this. It's an easy astrophotography target, but visually it's not really going to work too well for you unless you have the best view I ever had was down at the Winter Star Party one year. Somebody had a 36-inch telescope and it has stood out pretty good in that. So any questions about the Horsehead or the image? Okay, I just thought I'd show this. It's pretty interesting. A lot of people, when they see the Horsehead Nebula, they'll see the whole nebula, and then the Flame Nebula is down here on the left side. So usually those images include the flame, but I got a close-up of this one, so I'm all set there.
Bill, just one quick question. You said this was taken through your C11?
Yes,
Okay.
yep.
Okay, so if it's taken through the C11, what's causing the spike diffraction pattern?
Very good question. What I like to do, Riyadh, I'm a proponent of diffraction spikes on the stars. And typically, you normally only get diffraction spikes through Newtonians, and that's caused by the secondary arms or whatever that hold the secondary in.
Yeah, the vein. Yeah,
What I
veins.
do,
Yeah.
I put wires across the front of my telescope.
Okay.
And that gives me the diffraction spikes. I do the same thing with my refractor. I've got a diffraction spike mask on my refractor also. I mean, what can I say? I like diffraction spikes, and I'm going to continue doing them, and that's how I do it. I put wires across the front of the scope.
Okay, well, on a refractor, that would be sacrilegious a little bit.
But it still looks okay to me. Yep, Photoshop has there's astronomy tools that will put those diffraction spikes in there as well.
Right.
And you can
But
do
you know what,
for,
Adrian? I consider that those fake diffraction spikes. These are actually taken through the telescope. On Photoshop, you're fake.
Very
well,
nice, very nice.
Can't argue with that. So I've got some observation as February rolled around. There's one image I'm going to find, and then I'll quickly go through. I went for astronomical twilight, and I don't recall if I shared any images of me attempting to do that. Gonna share last year's and this year's. So let me go ahead, quickly share screen and go through this as fast as I can. So this was last year. At the moment that at astronomical dawn starts, your images take on if you're in a dark enough location, your images take on this bluish tone, and yet the Milky Way can still be visible. Now let's see if when it's not astronomical twilight, right before it, the coloring of the Milky Way is you've got this dark grayish sky, and you see the Milky Way here. It's bright, and once again, this happens. I went for this year, and somewhere in my ginormous set of pictures here, my results weren't as good as I had hoped, but I still did manage to get kind of that astronomical dawn. And here we go. Looking over Lake Huron at Port Sanilac, a beautiful place to go. Right now, the roadside park is technically closed, but you can pull up to the sign, and you can walk over to the area overlooking the lake, or you can go down. There's actually stairs you can go down, overlooking the lake, and you get some you get a Portal 3/Portal 4 sky there. And so that was the target. This is what happened to me when I tried to capture the core rising. I got clouds. Interesting effect, but those things happen. So what else did I do? So Bill showed you the horse head. If you do a real wide view of the region in Orion where the horse head is, here, as we zoom in, you can see it here. That's the flame. This was a 6-minute image. It was sort of a proof of concept. Could I use my Explorer scientific mount to get, a decent looking wide field image? Now, if I do 2 hours worth of data like Bill did, then this area, and get my settings right, this area becomes even crisper. I can do some things where the central dust column in the Orion Nebula would show up. There's some more technique that I would have to use to accurately represent these things. Yes.
Adrian, I'm glad you showed this picture because it makes my description of where it's located a whole lot easier for everybody to figure out.
Yeah. So that's where the horse head is, and Barnard 33 technical name. This so in a wide field view, you can see it, compare that to what you just saw with Bill Beer's image. There's so much more detail here than what I captured with this wide angle image, but it still stands out. These structures are huge, and yet to us, you could blot them out with your thumb. So, of course, the moon is in the sky, and really quick, when processing moon images, this is straight from the camera. Notice how there's some detail, but compare this image and the detail that you can see with some of the other shots that I took as the moon was growing. When you process the moon, you can run the risk of over processing it, or you're trying to show the type of detail that you want to see. The moon is very pockmarked. You can tell how bombarded it is if you process it in a way where you raise the texture and you see these things. Or you can be like Doug Bach and use a telescope and do some mosaics, and when you zoom in to the moon, you would keep zooming in. At some point, this is going to pixelate, and right about here, it's not all that good, right? Dug box images of the moon, you can keep going and you can get even more detail. Copernicus, the crater here, your instruments determine how much detail you will get with your moons. This is shot with a 600 millimeter camera. So we're going back in time this past week when Copernicus was near the Terminator. And there's some pretty good detail here for a handheld shot with a 600 millimeter lens, but it gets even cleaner than that if you use an actual telescope. So there are limits to the gear that you use, and it depends on what look you're doing. So all of you out there that we marvel at our astrophotography, what we learn is, well, what are we looking for? What do we want to present? And our gear is there to help us get to that, to show what it is that we are trying to present. So that took an awful long time. My apologies to all those, but hopefully it was informative too. And hopefully, Bill, you approve of me going into detail like that. But that's
Yeah,
going to be my
it just
report.
makes the location of that horse head easier for people to understand where it's at.
Yes, I would agree. All right, Bob or David, if we haven't let you give we haven't gone to the observation reports. We're chomping at the bit to do it. So let's turn it over. Bob, go ahead and take it from me, and I will let you lead us in.
Yeah, we're gonna do solar after David, so go ahead, Dr. Levy.
Thank you, and I'm glad to be here. And the sun is continuing to be active for me, although this week has been a little less active than last week. But I'm expecting that this cycle is going to continue to ramp up very, very strong.
It's not recognizes my headphones.
Well, anyway, I've been.
I went all the way back. It's not recognizing my headphones.
Hey, Jerry, can you mute yourself?
Sorry.
Is that a little better?
Yeah, David, you're good.
Okay, as I was saying, we've had we have had very nice sunspots, less than last week, but the cycle is rapidly climbing up. In the evening, I've been concentrating on a double star that I really like. It is Omicron. Omicron! We're all familiar with Omicron, but this one is not the variant. This is the triple star Omicron 2 Eridani. A very interesting star, only 16 light years away. The primary is a very bright naked eye star, about 4th magnitude. The secondary is a white dwarf, about 9th magnitude. The tertiary, believe it or not, is a red dwarf, about 11th magnitude. You need a fairly high power to see all three of them, but they're there. It's a beautiful, beautiful triple. Anyway, for my quotation of the meeting, I know we've all been following what's been happening in Ukraine, and a lot of us have been very depressed thinking about the state of our civilization as being so bad right now. But this is the same, we must remember, this is the same civilization that produced Aristotle, Shakespeare, Galileo, Copernicus, Einstein, and Vincent van Gogh. So there are some good things about the civilization of which we are a part. For my quotation today, I'm going to be quoting from Pritchiana, which is written about 1840 by Taras Shevchenko, popularly known as Ukraine's Shakespeare. about the Dnieper River. The mighty Dnieper roars and bellows. The wind in anger howls and raves. Down to the ground it bends the willows, and mountain high lifts up the waves. The pale-faced moon picked out this moment to peek out from behind a cloud. Like a canoe upon the ocean, it first tips up and then dips down. We can certainly hope for better times, and as it says in the 30th Psalm, weeping may tarry for the night, but joy cometh in the morning. And let's hope so. Back to you, Bob. Thank you.
Thank you, Dr. Levy. All right, I am going to do a quick share here, and we're going to take a look at the sun. All right, can you guys see the orange disk there?
Yes.
Okay,
Yes.
that is the sun from spaceweather.com. It's got a couple named sunspots, as you can see there. This stupid thing is right on top of my screen. Grr. So this is from the SDO. This is a zoom in of those sunspots. That is pretty cool. This is a video. I think it's 304 angstroms. Take a look right in the center about now. There's a prominence there. Blam! That thing comes out, and that bright orange spot on the top is spitting flares like crazy. So let's take a look at the corona now. Get out of there, stupid thing. Excuse me,
So,
cat.
Bob, we're seeing the other disc with those numbered sunspots.
Oh,
I
you're
don't know
not
if we.
seeing it change? Oh,
I don't think we're seeing it change.
oh, it's paused. Why is it paused? Stop sharing. Well,
There we go.
can I share that? All right. How about the orange? How about the orange disk now? Share application. There we go. Can you see the animation?
Yes, we can see it now.
Okay. This is the sun from the Solar Dynamics Observatory. It has a huge flare there, and that orange active region at the top is just spit, 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 spit. That's pretty active, but that's rotating out of view. This is the well, darn it all. Well, that share bar is right on top of my screen. That's really annoying. So yeah, the sun is again we're coming up to solar maximum. I'm expecting to see a lot of spots. The last couple of weeks that I've been reporting, there have been at least 4 named active regions on the sun. There's only a couple today though, but we're ramping up. I'm expecting this to be a fairly exciting solar maximum. So we are at 8 o'clock right now. This is typically when we take our break and reconvene about 8:20, 25-ish. I see our lecturer is here. I might want to speak with him during the break really quick here. So everyone, take 15, 20 and meet back about 20 after. And if you want to stay on and chat astronomy, you can do that.
David, I found a picture of when I went down to Arizona to watch the transit of Venus, and I have a picture of Eli Mayer. I'm trying to find it. I wanted to show it to you.
Sure.
I've got it here somewhere. I'm looking for it.
Right.
He and his wife, I guess, were with him at the time.
Yeah. Ellie and Dahlia were with us to see that transit.
Yep, because they went to see you right after that.
Yeah.
And I'm trying to find it now. I guess I could find it this way. Let me see if I can find that. Let's do it this way. I can go back to the dates is what I can do. Well, it was in 2012, right?
Yeah.
Let me find it and see if I can get it, raise it up here. I think you'd get a kick out of this. It was June of 2008.
Yeah, June of 2012.
Right. Let's see if I can get it up here. I'm gaining on it, I swear. I think I got it. Here it is. I think I can get the picture of him. Hold on. June of 2012. Get that picture of, yeah, there it is. There it is. Let me see if I can raise it. How about that? You got
Well,
it?
it's coming on.
That's him, isn't it?
There it is. Oh, yeah.
How about that?
It's Dahlia and Dahlia. What a beautiful image.
Yeah, he
They're
was
really
such,
dear friends of ours.
they were, he was, you know, he spoke before the club
So,
a number of years ago.
oh,
For the banquet. He came to the banquet and he spoke about his book. You know, he had that book. God, if I could, wish I could remember it. But I thought you'd get a kick out of that picture.
I sure did. Thanks for sharing it with us, Ken.
Sure. I'll take us off of there too. By the way, the interesting thing about this set of pictures is, let's see if I can do this. There he is. Right after that, I went to see there it is. That's the picture that I took from there. That was by, I think that was by, no, I actually took this off the internet. There's the picture of Venus transiting. And of course it was very active. And I went to the 2004 transit in Greece and there was no activity at all, you know, but this one had a lot of activity.
Mhm.
How about that?
That's really a beautiful picture.
Yeah.
Good, wonderful memory.
It was a great memory. There's no question about it. It was just so cool. And what was that other one? I have one. I was, of course, you know, I'm a graduate of the University of Arizona.
Oh,
So
really? In what
yeah,
field, Ken?
I actually was in finance. I got talked out of becoming an astronomer by G.P. Kuiper, by the way.
Oh, really? Why would have done that?
Well, it was interesting. I went there. It's a great old story. He was the lead professor at University of Arizona.
Yeah.
And he was an interesting guy. He was a hard guy, but he was an interesting guy. But when I was a freshman, I went down there and I went to the lunar lab, or I guess the lunar planetary lab is there. And I was wandering through the halls and he's walking through there. And there's this young punk freshman, right? Comes up to me and he says to me, "What's your name?" You know, nobody else was there but just me. And I talked to him for a few minutes. And then I took an astronomy course and I took several of them. And what happened was, when it was time to declare my major, I went into him and I said to him, you know, doctor, I said, what do you think? He says, well, he says, you know, I've done a little research on you. Your dad's in the insurance business, makes a lot of money. He said, I make $22,000 a year as the head of astronomy at the University of Arizona, you know, 22, 23, something like that. And he says, keep it as an avocation. He says, go into business, and you'll be able to buy any telescope you want, join any clubs, do all that other stuff. And he says, I'll take you over to the leader of the business school. And he introduced me to the leader of the business school, and I declared my major. But I still spent time with him for the next couple of years while I was there. It's a great story.
Wonderful story.
Yeah, he was a
wonderful man.
Mr. Kuiper of the Kuiper Belt.
That's the guy.
Yes.
Okay.
And he said, and he said it to me. He said, you know, I'd love to have you in our field and blah blah blah. He says, but you're not going to make any money. I thought it was so.
Well, you know, had you done it, you might not have been rich, but we might be calling it the Burton Belt. I don't know.
Who the hell? Yeah, no, I don't think so. I think he was well on his way to naming it already. But
Okay.
that's 1963, actually, is when it was. So
Kuiper passed away about 10 years after that.
after that, right? And I kept in touch with him while I was at school, and he was a nice man to me. You know, I know he was a tough guy, but he was as nice as you could imagine. Nice man.
Yeah.
And but it was funny.
So,
I'd go
has
out.
any-
Go ahead.
Sorry, go ahead.
I was just saying I'd go out when they'd have observing service things, and I would point out things to some of the newer, you know, the younger, the freshmen and so on and so forth. And used to have a great time with it. It was super, great fun.
So
But
has anyone here been to the McDonald Observatory? Because I'm going to be going to it in a couple of weeks.
Many times, many times.
Yeah, absolutely.
Yeah, I'm going to be going with my wife and my daughter and her husband. They're going to be joining us, and we've got tickets for solar observing, a star party, and a general tour type thing. So that'll be pretty cool. And we're also staying at Big Bend in the domes. So
how cool.
Yeah, that'll be very cool.
It was a great
Astronomy vacation. Woohoo.
It was a great experience. I got to tell you, I loved doing it. I loved being in it, and it was just it was a blast. I loved being in Arizona. I always used to tell people that I never allowed my schooling to interfere with my education while I was there. You know, it's like it was a beauty pageant. It was really something else.
Hey,
Bob,
Bob, have you looked at the opportunities to look through their 36-inch or
I
88
certainly
inch?
did. I looked through the 36-inch. Yes, I did.
Yeah.
Pretty cool. And they have a very, very pretty 16-inch there too at Kidd Peak. That is really a beautiful telescope. Anyway.
Piece of information for you, Bob. Bob Trombley. If you have the opportunity to go to one of their private star parties, they're really pretty cool. You can look through, they actually take the video camera off of the 88-inch telescope and put eyepieces on it. You can go to that. I think it's like you pay $75 to become a member, and as a family, so that pays for 2 people. I'm sure they have a price for 4 people as well. But then they have you get first choice to go to those events. So if it coincides with your trip, that would be really exciting. I did that, and we looked through the 36-inch when we were there 2 years ago. It was pretty spectacular.
Man.
Actually,
that
for that
sounds cool.
$75, it actually entitles you to stay at the astronomer's lodge if they have vacancies. And in my instance, they did. So we are directly, I mean, you walk out the door and you walk across a 10-foot wide street, and there's the pathway up to the observatory. It's like, and it is pitch black. It is awesome.
Wow.
So Bob, we were down there
I can't wait.
a few months ago. We we drove by the observatory there, but they were closed that day. That wasn't our destination.
Boo.
We went down for the Grand Prix in Austin, and then we spent a few days visiting some family, and then we went to Big Bend National Park, which I did do some nightscape astronomy stuff there, Milky Way stuff, and that's great. So you are going to Big Bend National Park?
Yeah.
Where are you staying?
Yep. Oh God. Under the Bubble Dome Hotel. They've got these clear bubbles with beds in them, and little fire pits with chairs outside.
Is that Interlingua?
I don't know.
Okay. I think I recall seeing something about that. We stayed actually in the park for 3 nights and outside the park 1 night, but it's all good for dark skies.
Yeah. Dale, you showed me some pictures you took. They brought back memories of being at skies dark like that, where Milky Way horizon to horizon, air glow and stars galore. Your eyes can only see so much, but the more they get adapted, you start seeing swirls and all sorts of other dust lanes in the Milky Way. I think you can see the North American Nebula naked eye in a sky like that. You don't see the hydrogen emission, but you see the shape.
Huh. Well, I didn't, but I wasn't looking for it either. I didn't think you could see it.
Yeah, you can. I was studying it with
Binoculars probably
binoculars.
easy. Yeah. So I wanted to drive by the observatory. I looked online. It's like, man, they're closed on Mondays, or it's like of the one day we're driving by to take a visit, like even for an open house and during the day just for a visit, and they were closed. So, like next time we get down there, I want to make a point and spend some time because that's a nice region. So, but yeah.
So Doug is here right now, right? Adrian, that I could probably ask him, right?
Yeah. Doug, Ken was looking for a good image of the Ring Nebula for a presentation he's doing in May. And I told him I knew somebody who probably had about 16 versions of it. And he wants he'd like to use the version of the Ring Nebula. I think, Ken, you can tell him the type of presentation you wanted to do, and you wanted to give credit to the photographer, the astrophotographer who takes it.
And Jennifer Dye is runs that thing for the Detroit Library. I'm giving it on May 26th, and she says she likes the pictures if we can get it and give some credit. So I could give you some credit if you can get me a picture, and I'll just use it, let her put it on her site. I want to use that and the Crab Nebula. I have a Crab Nebula that looks just fine, and it's got some credits to it too. But if you could do that for me, I'd appreciate it, Doug. Doug? I don't think he hears me.
Yeah, no, I hear you.
Okay.
I was reading, but I don't know. Let's see. What do I got here? Why don't you pick one of these?
Okay.
Here.
How are we doing on time, Bob?
About ready to start pretty quick.
About 2 minutes.
Okay.
That's enough time.
About 1 minute.
Perfect. All I need.
Even better if you want to immerse it in space, because that's it's a fairly, is it because it's distant that it's smaller?
Well, I want to get a little bigger because it really is the result of what happens to the Earth later on. So the first one you had looked like it was perfect. Yeah, it's fine. That's beautiful.
Okay.
You want to email it to me? It's fine. You can do that if you want.
Yeah, just give me your email. Just
SY.
No. Just put it in the chat privately to me.
I'll do that. Yeah, I'll do that right now. Absolutely. Okay. Thanks. Appreciate it, pal.
Yep.
Let me do that.
I figured you had about 16 of them, Doug.
No, I've only got a few, just a couple, 3 maybe. I haven't taken that in a long time.
Okay, so it
maybe
is
I
8:20.
exaggerate a bit. Go ahead, Bob.
It's 8:20. Get back into your seats and let's get ready to start this show. Okay. Andrew says he's ready. All right, so tonight's guest is Andrew Gangidine. He's the curator of Earth and Space Sciences at Cranbrook Institute of Science. His intro here in the WASP reads: billions of years before humans walked the Earth, our planet was inhabited solely by microscopic life. Searching for evidence of ancient microbial life on Earth is challenging, as non-living phenomena can mimic the simple morphology of microbial organisms, and the passage of time can distort microbial fossils. On Mars, the search for microbial life will be even more challenging, since we do not know that life ever arose there. He's going to be talking about this, and Andrew, take it away.
Yep, sounds good. Can you hear me all right?
Perfect.
You're fine.
All right, awesome. Let me share my screen here. All right, so hopefully there is enough space in this to not make you too bored of the geology and biology you're about to listen to. So I'm going to try to leave some time for questions at the end there. So feel free to write anything down and let me know what you think. So thank you for that intro, and thanks for having me. It's great to be here. I've enjoyed watching all of the, or seeing all the cool pictures that you've been sharing so far. I have a tiny telescope that I can use for looking at the moon, and that's about it. But this is dangerous because now you're making me want to get something more substantial.
We can fix that for you.
Yeah. That was not an attempt at begging, but yeah, thank you.
Bring your checkbook.
Yeah, I know, right?
These people are good at spending your money.
Yep. It's a dangerous hobby, is what I hear. All right, so title of my talk that I'm giving here: Ancient Fossils and the Search for Life on Mars. So I'm going to talk a little bit about my own background. So I got my PhD in 2020 from the University of Cincinnati, and a lot of what I did was focused on astrobiology. So what is astrobiology? It's a fair question. I like to start all of my talks here at Cranbrook with this because most folks don't know it's a relatively up and coming, and also, it has astro and biology in there, but it's really not a fair term because it's really defined here as the study of the origin, evolution, distribution, and future of life in the universe. So that entails basically every branch of science. So you've got, the study of the origin of life, you've got prebiotic chemistry, biology, geology, even when you get to some of the astronomy, of course, but when you get to the future of life in the universe, there's some folks who are coining new terms such as astrosociology for, it's a big issue if we're going to be talking about potentially colonizing other planets. You got to make sure the people like each other. You can have some bad news if communication issues happen, and so there's a lot of, or what'll it do to people if they have to live in a colony on Mars and can't go outside, get homesick. There's a lot of interesting stuff. So astrobiology is a pretty broad field. So my own background, as you may have gathered from my intro, is a decent mix of biology and geology. So with that, let me show you a little bit more of what I do here. So when you think of studying ancient life on Earth, this might be the first type of stuff that comes to mind. Here's a little shout out for Cranbrook here first. Got our famous T-Rex Black Beauty here, which you can see if you ever wander the halls of our museum. And if you're a little bit more into paleontology, you might be familiar with the trilobites or brachiopods, some classic mainstay fossils here. But what I want to make sure is illustrated is the time between when the Earth formed, the ancient Hadean Earth, to the modern Earth, is this massive, about 4.5 billion years. That's a long time. What I want to put on a timeline here is just how, put this into perspective a little bit, just how close, for instance, the T-Rex is to modern Earth when you plot it roughly on this timeline. So 66 million years ago, it's a long time ago, but look how close that is to where we are in modern Earth. Now those trilobites and brachiopods, much farther away, over 500 million years ago, but again, still pretty close to modern Earth on this timeline. Now we have a lot of evidence for fossils before this. The problem is it gets pretty difficult to look for them. So currently, and there are some people who would argue with me about this, but the most convincing evidence, last I checked, there's always new things being discovered and then debated back and forth. Currently, the oldest estimate is at 3.5 billion years old. We're pretty sure we have some good evidence for life. But everything in this range, you need a microscope for, and it can be pretty cryptic to be able to tell what you're looking at. So some of the oldest environments that are preserved on Earth are hot spring environments. This is where my research specialty comes in. This specific spring that you're looking at right here, maybe some of you have been here before, this is at Yellowstone National Park. So this is Grand Prismatic, fittingly named for, look at all the pretty colors that you're seeing here. But if you were to go take a sample of the water or some of these outflow streams right here and put what you find under a microscope, this is what you would find inside. They're filled with microscopic organisms, typically cyanobacteria, microscopic organisms that use the sun for energy using photosynthesis, typically is what we find. At least a lot of them are populating these springs. There's also a lot of archaea. A lot of these springs are super hot. Some can be super acidic. You have a whole wide variety of geochemical conditions. So this is also a hot place to study, no pun intended, extremophiles. So this is where I did a lot of my research. Here's me trekking through some of the marshes in Yellowstone. Always interesting. I've been going with one of my colleagues, Dr. Jeff Havig, who's been in Yellowstone for a lot longer than I have, and he knows the right ways to walk. He knows how to make sure if you run into a bear, first of all, how to try to avoid that as much as possible, but what to do if that does happen. So my advice, if anyone wants to take some trips to Yellowstone, is make sure you know what you're doing and don't go off the path, because every now and then you hear those stories of tourists that get a little bit too close to the boardwalk or off the boardwalk, too close to the springs. They don't realize how undercut the ground is there, and they fall in and typically don't have a good time with that. So here is, I'm right there, and here's my PhD advisor, Dr. Andrew Chaya. We're standing on the side of a hot spring here. This is called Steep Cone Hot Spring, and again, in Yellowstone. So the actual top of the spring is up here. The way this structure forms is, and let me give you a little zoomed in view right here. What you're seeing here is varying layers of silica sinter. So that's what, it's silicon dioxide. And what happens is it crashes out of solution from the water, and it forms this structure gradually over tens of thousands of years. What you're seeing here is one layer, then a second layer, then another layer, and this just repeats and repeats and repeats. So let me show you what happens if you were to take a sample from the very top. This is what I found inside of it. These are what we call silicified, so basically entombed, encased. The only reason I don't say fossilized is because there's a little bit of terminology that goes behind fossilization that has to have a certain amount of time that goes along with it. Some people argue 10,000 years. It does get kind of arbitrary, to be honest, but these are organisms that were living in the streams themselves or in the outflow streams, and as this silica crashes out of solution, they become entombed and very nicely preserved. So if you take some samples from the very top of the spring, this is what you're going to find. They still have their pigment, but if you were to take a sample from the lower part of the stream, this is what you find, or the lower part of the structure here, this is what you find. So you can see evidence of the same type of microorganisms, but they've lost their pigment, but you can see they're the same size, morphology. And we think top to bottom for this structure is right around 10,000 years, give or take a couple thousand years in either direction. But this whole area was carved out by glaciers around 14,000 years ago. So it's a relatively young structure in terms of geologic time. But this is a zoomed in image. This is a scanning electron microscope image from one of my colleagues, Dr. Jeff Hannon. This is what precipitated silica looks like. So when it crashes out of solution from the hot springs, this is how it deposits. This is called a botryoidal texture. And it looks like a bunch of little spheres, as you can see here. So this is an SEM picture of an actual individual microbial filament. So you can see this is the actual body of the filament, and you can see it has this little armorous coating. If you zoom in on that there, you can see it's just getting covered in silica. And so they don't normally look like they have this break in them. This just happened to dry out and desiccate, and that's where I got the photo of it. So typically they're pretty coated from top to bottom, and this is how you can see they could get entombed like that. So it might not be immediately obvious. This is a technique that is pretty unique to a lot of geology or paleobiology. You might be wondering, how am I getting these images that you're seeing here? And the process by which we get those images is called thin sectioning. So here's how you do that, and in general, how you search for microscopic fossils. So step one, and this is the arguably most difficult step, is you got to find a spot where you think there might be microscopic fossils. Sometimes that's easier than others. I've known, unfortunately, a lot of astrobiologists, paleobiologists who have done field expeditions, and it's not like digging for dinosaur fossils where if you dig and dig and you don't find anything, that's the end of that. You won't know oftentimes until you get back to the lab if the rocks that you've collected actually have any microfossils in them. Sometimes, as I tried to illustrate here crudely, as you can see, a little bit of a wavy structure, or something that looks not quite abiotic or non-living on a rock. So you get your rocks of interest, then you're going to take them to a saw and you're going to cut a flat edge. After that, you're going to glue that flat edge onto a microscope slide. Then you take it back to another saw and you're going to grind off most of it until just a little bit is left. And then you can take it to a grinding disc or a polishing pad until it's so thin that you can actually pass light through the material. And with that, you get your microscope, you get your thin section, you put it on there, and you can go looking. So here's an example, again, like I showed you on the last slide, of what it might look like if you're looking at a thin section of a recently silicified microorganism. So what I did for my PhD research is I was trying to look at something called a biosignature. As you might be able to guess from the name, a biosignature is a sign of biology, is the quick and dirty way of describing what that is. So it's some type of chemical or molecular signal that is unique to life. So you think about it, living things interact differently with their environment than non-living things. We have enzymes, we have metabolisms, we have typically some way of taking things in and putting things back out. So what I did for my PhD research is I was interested in trace elements, so elements that appear at very small concentrations in hot springs. I was wondering, if you were to map these microbial remains, would you actually be able to find any discernible signatures from these trace elements? So here's an example of what I mean. Using a technique, an instrument called secondary ion mass spectrometry, I was able to scan over some of these microbial remains and image whatever elemental concentration was there. So here's a brief illustration. So this is me mapping for nitrogen, and look again. So this in the center from the top left corner to the bottom right, that is the actual body of the microorganism there. And what I was finding, there's an example of nitrogen, there's chromium, manganese, gallium, iron. What I was finding is a bunch of different elements, and I'll go through those one more time, seem to be sequestered inside of the remains. So the tricky part is determining now, is this something that's happening to the remains, or is this something that's actually specific to their being living organisms interacting with their environment? If it is something that's due to them being biological, this could be something, as people are hunting for microbial fossils on Earth or on other planets, that this might be able to be a technique that they can use to see if you're looking for a fossil and it lights up with some of these elements. That's another piece of convincing evidence, because if you think about it, these things are pretty small. They're very simple in size, or very simple in morphology. So small size, simple morphology. They can easily be mistaken for something that's abiological. For instance, a gas bubble, a mineral chain, something like that, and you want to be sure that you're not misidentifying. So biosignatures are great because any additional lines of evidence to argue for or against something being a fossil is great to have. So the next step with this is, since we have a lot of older hot springs on Earth, I wanted to extend this back to more altered samples. So here is a chunk of hot spring 350 million years old from Queensland, Australia. This one took a lot of sleuthing, but after several thin sections, did manage to find some stuff that, once again, looks like microbial remains. So I've got the arrows there showing each one of them. So if you're looking at that, you might be able to see why it's easy to miss them, and it's also easy to mistake them. So one method that we use here, and watch in the center here, this is a technique called confocal laser scanning microscopy. So one thing, in order to prove that it's not a mineral chain, is you want to be able to tell that it's hollow, because living organism cells are hollow. You know, they need to have an inside and outside. They're not completely solid. And also, this specific type of laser wavelength that we're using interacts and makes organic material fluoresce. This is also a good way to find out if what you're looking at is made of carbon, as all living things are. So putting all of these layers together, we can reconstruct that, and we have our laser microscopy image of our bacterial fossil here, 350 million years later. Pretty well preserved, all things considered. The next thing I wanted to do is see, do we find any elements that are still sequestered along with these fossilized remains? So if I can direct your attention to the bottom left here, I did the same type of technique. Once again, it lights up with carbon. That's great. That's always very important. But you see a lot of other elements. There's magnesium there that distinctly are in higher concentrations in the body of the fossil as opposed to in the surrounding mineral matrix. And the important thing with anything that you want to do in science is to make sure that you're not just looking at something happening once. So I analyzed several microfossils in this way. This is the recent paper I published on this, where several different microbial fossils, and once again, consistently they would light up with carbon, sulfur, magnesium, aluminum, manganese, iron, strontium. It's important to note too that not all of the elements that I found in the Yellowstone samples I could also find in here. For instance, gallium was really present in Yellowstone, but I didn't see that at all in these older samples. So what that means exactly is still something I'm trying to figure out. You know, it could be that for some reason the bacteria from the Yellowstone springs uniquely utilize gallium, or it could be that these older microorganisms, when they were alive, also used gallium, but it wasn't preserved for some reason. So there's a lot of tricky stuff like that that's hard to figure out that, you know, I'm currently still working through. So I know I've been talking about astrobiology, but I haven't left Earth so far. So let's move on to the next planet here, which is Mars. So looking at this, it might not scream to you signs of life or a great place to live, either for humans or microorganisms, but scientists have good reason to believe that Mars used to look something like this. And this changes all the time. How much water there was, where it was located. People keep going back and forth when it exactly existed on the planet. But due to a lot of evidence we have for rivers, ancient shorelines, streams, we know Mars was at one point likely had a lot of water on it. So because we think, due to several different factors, but one of them is that Mars is about half the size of Earth, it eventually cooled down, it lost a bit of its magnetic field. Eventually, a lot of that water was lost to space, and what little remained, a lot of it got either froze or a little bit sucked underground, at least slightly. So the other interesting thing, at least for me, is that here's an aerial view of a hot spring from Yellowstone. right next to Steep Cone, actually. There's been some who suggest there's evidence on Mars for extinct hot springs. The home plate region in particular is an area that's been proposed to potentially be a extinct hot spring on Mars. This was actually visited by the Spirit rover. Again, people are still debating this, whether or not what it found was evidence of extinct hot springs or something that just looked like extinct hot springs. The problem, I mean, the great part about the rovers is we wouldn't know any of this stuff if we didn't send the rovers there. But, you know, it opens up a can of worms every time where we send the rover there and then scientists want to go back and answer all these other questions that have emerged. So, for instance, we do know that this home plate region is made of silica, just like a lot of these hot springs we're seeing at Yellowstone. But they didn't know that until the rover actually landed there and its wheels started spinning, and it kicked up and it revealed that there was a bunch of powdery white substance beneath the surface there. So it just goes to show you really got to get to someplace on Mars before you truly understand the geology and everything that's going on there. But that brings me to our current rover on Mars. Well, we still have several that are doing at least something on Mars, but Perseverance just landed at the start of last year. This is what I would like to spend most of the rest of my time talking to you about. So Perseverance, if you follow this stuff, might look familiar to you. It uses very close to the same build as the Curiosity rover. The main difference is this arm right here, which I'll describe more to you in a moment. But the primary mission objective of the Perseverance rover is that it is searching for signs of past life on Mars. Important, not current life. It's not trying to look for anything that's, you know, I suppose it could accidentally stumble upon it, but it's not there to turn over rocks and look if there's any microorganisms currently living on there. It's looking for signs of past fossil life on Mars. This is where it landed. It's in Jezero Crater. It's a little bit hard to see here, but right where I'm pointing to right here is actually a crater rim. And you can see there was a stream that cut through the side here, a little river right here. And what this giant structure is actually a river delta, which we believe at one point the crater itself was filled with calmer water. And just like what happens, how deltas form on Earth, the rapid sediment that was being carried hit a calmer, standing still, or mostly standing still, water source in the crater, and it dumped a bunch of sediment. So that was another reason that scientists were really excited to go here, because river deltas are great places to preserve organics or carbon, which are, you know, very often on Earth, surefire signs of life. This is the current proposed path of the rover. It's eventually, and again, we'll see what happens, but it's eventually planning on making its way to where this star is right here, which I'm personally excited about because there's the potential at the end, at this rim, there'll be some evidence of impact-induced hydrothermal activity. So we could find some evidence of extinct hot springs at the rim of the crater. We probably wouldn't find anything that's not a piece of float that's been carried in until we get there, just because a lot of this floor of this crater has been covered up by this sediment. But the unique thing this rover is doing is that it has these sample tubes that it got sent with. So they still mostly look like this. There's been some color changes. This is a prototype of the tube. But let me show you what exactly this rover is doing. So you can see the robotic arm there. So this rover is able to go over and actually drill into any rock of interest. And what it does is it pulls up a tiny, almost pinky-sized drill core, brings it back to the rover, and loads it into one of these sample tubes. Then it will grab the tube and seal it. And eventually the plan is to leave all of the tubes on the ground. Now that might sound like, why are we spending all of this money to go litter on Mars, essentially? But don't worry, we're going back for them. This mission has not been given firm dates yet, but last I heard it was something like in another 4 or 5 years or something, we plan to send another rover. So the Perseverance rover is about the size of a car. This will be a much smaller rover, but you can see here it's got a little claw here to be able to actually pick up the sample tubes. And again, these are still prototypes. I'm not sure if they've updated these designs since the last time I've looked into them, but it's going to be loading these tubes into a little caching container inside of this structure right here. And then with that, it will be launching them to be returned to Earth for more detailed analyses. And currently, again, last I heard, the best guess for that is by around 2030, and that's if all goes well. Who knows if COVID delayed that any further? A lot of this stuff is we're just going to have to see how things go with the rest of the mission. But the reason we're doing this is because rovers are amazing in terms of the science they can do given their size, but we can't miniaturize stuff too far down without sacrificing some type of resolution. So the lab capabilities and the science capabilities we have on Earth are always going to be a lot better than whatever we can put on a rover. So we're going to be sending several sample tubes that we collect from Mars back to Earth for study. Some of them will be, the primary purpose of them will be for astrobiology potential, and some of them will actually just be more planetary geology, stuff that we can better talk about with more confidence the history of the planet of Mars. So sometime in about a decade, give or take, we might have these samples back here, and we can look at them and find some cool stuff in there. But I thought you might be interested in seeing a little more of the scientific process. This was something that I was involved with throughout my PhD, starting back in around 2016. I attended several of these landing site workshops that were hosted by NASA. This is when, before the actual landing site for the rover was finalized, scientists who were experts on all these different areas on Mars essentially got together and pitched why their landing site would be a great place to look for evidence of past life on Mars. And so here's an example of the selection criteria. This is from one of the workshops here, but this is what was determined to be important for a landing site. So step one was very important to have a characterizable geologic setting and history. Essentially, if we're looking for past life and it's not in an area where we're sure of how old the stuff is, that's going to be a problem, because we want to be able to say if we get something that it's ancient. If we did find anything, we need to be able to figure out what's going on there, especially with the geologic setting. Is this someplace that back in the day could have harbored life, we think? There's a lot of places on Mars where we're not sure about that. Thankfully, there's a lot of other places where we do think we can get a lot of specificity with that. The next important part is that it needed to have an ancient habitable environment. So someplace that we think, and whatever you define as ancient, some of these sites varied by a couple billion years sometimes, but at least a long time ago in the past, that environment was habitable, as opposed to someplace that might still be habitable or more recently habitable. The next part is it needed to be a site that had a high biosignature preservation potential. So this is a good time to mention that for fossils, the vast majority, and this is true on Earth, the vast majority of any organism, be it microbial or something more complex like you and I, vast majority of remains are not preserved. Things die and they degrade, and there's really no evidence. And that's especially true of microbial life. They're relatively, they're extremely small, relatively easy to be immediately completely destroyed when they die, such that if you're looking at something, you might find some organic sludge lying around, but stuff doesn't get preserved very often. So we wanted to find some type of setting that had a high biosignature preservation potential. So if we were looking for signs of past life, we could be sure that if it were ever there, it would be a spot where it would be preserved. This one was the astrobiological quality of returned samples. A little more nebulous, but what would this tell us about the potential for Mars to have hosted life? This was something like, if we found something, a chemical, an organic molecule might be convincing, but it wouldn't be as convincing as, say, a body fossil, and neither of those by themselves would be as convincing as a body fossil plus an organic signature. So you want as many lines of evidence as possible. And the last part is the petrological quality of return samples. So we want the mission to be successful even if we never find any evidence of life on Mars, that we still find a lot out about the planet, and it still keeps at least the geologists happy. So when I jumped into this landing site, these working groups, there were this is kind of where I jumped in. There's around 20 something sites left, and there was, think of any type of consideration, even that you don't see up here, and it was a factor. One of the first things to really narrow down the list, because this list at one point was over 100 landing sites long. How close are things to the equator? Because if the rover is going to be experiencing frequent bouts of extreme cold, that will limit its lifespan and its ability to function in general. Terrain was also a very important aspect. Do we have to worry about the rover not being able to move over jagged rocks, or God forbid tipping over, something like that? But you can see here, this is what happened. If I can go back here, scientists would hear these meetings, and then we would get a vote at the end. And you can see here some of the results of this. So the last 2 to 3 years was just debating Jezero, Columbia Hills, and Northeast Syrtis. They were all strong contenders, but as you might imagine, once you get down to the top 3, the competition was a lot more fierce. So this was a cool thing to be a part of. And when I say I was able to vote on this, I wasn't the one who formally pulled the trigger and got to decide where we were going for Mars. This was the scientists who were essentially invited there to give their opinion, which was then kicked back to participating NASA officials, especially those running this mission, and they were the ones to eventually make that decision. What I will say is, I remember asking my PhD advisor, when this list was still dozens long, what he thought the outcome would be. And he did say probably Jezero. It was a very strong contender from the beginning. And as you can see here, from all of its scores for all these different things, it was consistently very, very good. Columbia Hills is, you might remember that's where the Spirit rover actually landed, that we thought we saw evidence of potential hot springs before. One of the major cons for that place is, one, we sent a rover there a while ago, and we weren't necessarily sure how good our sterile technique was. We don't want to have something happen where we're going to look for signs of life on Mars and we accidentally identify life from Earth that hitched a ride. But the other thing was, even though the Spirit rover was substantially older than the Perseverance rover, it still was pretty capable, and it did a lot of science in that area. So because the rovers, we still have not been to the vast majority of Mars, so the ability to go to a new site, even though Columbia Hills was pretty interesting because of the hot spring potential, that was a big boost for Jezero as well. And so in my time at these meetings, I got to see a little bit more of the inner workings of how do you plan for a mission? So I showed you that animation of the rover drilling into those rocks. Stuff you might not immediately think of. I know I didn't, but you need to figure out what's the best drill to be able to do that. And the best type of drill also depends on the type of rock that you are drilling into. So they had several different types of rocks that are analogous to what we would expect to find on the surface of Mars at these various landing sites. And if you can look at some of these tubes here, you can see there were some problems with drilling into some of the softer rocks. A lot of them, like the more silica sinter rocks that like you would find in a hot spring, because they were so brittle, they would shatter oftentimes. And we don't want to go through all the trouble of bringing back cores from Mars only to bring back essentially rock dust because we're obliterating the sample. And if they did contain any potential evidence of life in them that we, a well-preserved Martian fossil that we then shatter when we're collecting it, that's no good. And here's another, this is just a prototype of what they eventually plan to, and the final design looks more sleek than this, but this is similar to what they're going to load those samples back into to send back to Earth. So there's a lot that went into this, and I wasn't the one designing these drill bits or anything like that, but it was still very cool to see all the engineering that goes into something like this. So to summarize a lot of the points I've just mentioned here, what we know about Mars is as follows. So we have a lot of evidence that Mars was once warm, at least warmer, and wet. We also have a lot of evidence that life likely evolved on Earth within about 1 billion years of the planet forming. And we think there's going, at some point in that window, there was liquid water on Mars. So it's conceivable that life on Mars could have gotten started in that same window. And we also have evidence of microbial life that can be found in both modern and ancient, what we call Mars analog environments on Earth. So environments on Earth that we think are analogous to what we would find on Mars. My own personal specialty being hot springs. But I also would like to mention what we don't know. We don't know if life ever evolved on Mars. There's no real way to be sure about this until we find anything like that. We know there's water. We know Mars had a lot of the elements that life needed. There's even some colleagues of mine who have submitted recent papers that very convincingly argue that a very likely spot for life to have originated on Earth was at terrestrial hot springs, kind of like you would find in Yellowstone. So the fact that we see these on Mars gives us some hope that it could have happened, but it's also possible, for whatever reason, maybe life didn't evolve on Mars, in which case we'll just have to go there and do some cool geology anyway. And that's why we're sending the Perseverance rover to look there. It's also important to mention that if we don't find any evidence of life at Jezero Crater, that's not like game over, case closed. It could just be we didn't look in the right spot, which brings me to my final point here is we don't know the best place to search for life on Mars. That was what these landing site workshops were for. I know at least some scientists disagree. They think some of the other landing sites would have been a better place to look. A lot of this stuff, I think, is going to have to wait until we can more easily access Mars and actually get maybe humans there to actually go out and do some geology where they're actually picking up rocks and maybe have their own thin section laboratory on Mars where, they're not relying on pinky-sized samples to get back here. But one way or another, this mission will tell us a tremendous amount about the history of Mars, and it'll help us understand it a lot more than we currently do. So for my last slide here, this is kind of more of just a thought exercise. So imagine we get a sample back from Mars from the Perseverance mission. Say we make a thin section out of it. And let's say you find this structure when you're looking under a microscope. And now you have to ask yourself, did I find evidence of alien life? Because again, even if it's just a microorganism from another planet, that's alien life. It's life that did not originate on Earth. So if you just saw something like this, are you able to convincingly say this is life, evidence of life outside of Earth? Because as you can imagine, that'll get the press going. That will be something that, I mean, it could really launch, you know, it could really focus what NASA's doing for the next several decades if we have evidence that life exists outside of Earth. That would be a huge paradigm shift for all of science, I think. But would it make you more confident if you were able to do some tests and you said, okay, this little structure I see in the center, it's organic, it's made from carbon, as a lot of living things on Earth are. And let's say you can do some more tests, maybe you do that confocal laser scanning microscopy that I showed you before, and you determine this structure is hollow. And then how about if you figure out the structure in this image falls within a standard microbial size range. So this is something that is about the same size, shape, diameter as a microorganism on Earth. And then how about the structure in this image was found in a sample collected from a supposed ancient hot spring, because we know those environments on Earth can preserve evidence of ancient life. And then how about one final one here? The structure in this image exhibits several chemical biosignatures consistent with microorganisms preserved in hot springs on Earth. So all I'm trying to illustrate here is, even if you have all of these, is that enough to convincingly argue you found evidence of alien life? Maybe not. I know some people would say, no, that you need more evidence than this, but it's at least better to have all 5 of these or 4 of them, and or if not 3, then to have 1 or, you know, nothing at all. So it's just, this is kind of what it's like to do some of this biosignature stuff. And I can tell you, this is type of science they do on ancient life on Earth. A lot of the earliest evidence of life on Earth, you'll have a paper come out that says, we found some of the oldest evidence of life. And then another paper comes out that says, no, you didn't. That's something abiotic. And then the other author writes a retort paper, and people go back and forth, and people make careers out of it, to be honest. So I hope this was informative and hopefully at least a little bit interesting. I like to end these not with you know, the end or anything like that, but to be continued, because this stuff is just starting to get underway. We have more astrobiology missions that are being sent to some other planets. There's even some recent evidence and some disagreement, debate back and forth about potential signs of life on Venus. Some of the moons of Jupiter and Saturn, they're having missions sent to them later on that might have signs of life on them as well. So this field is really just getting started. Some funding acknowledgements here that supported a lot of my research there. And also a very nice picture of Cranbrook here to invite you to come on by sometime. I don't know, I know you all used to meet here. I've only been here since October, so I don't think I've overlapped with any of your meetings here, but we got some cool stuff here. I'm happy to show you around, get a cup of coffee, something like that. So I'll be around here. And with that, I will take any questions if we have time for that. And thanks for listening.
Thank you very much. Anybody? I have a question if nobody else has one.
Go for it.
Okay. So assuming, let's say that we do, or they do confirm that life is on Mars.
Mm-hmm.
What then? Do any planetary protection protocols come in mind? What happens with future missions and rovers? I mean, do we allow humans to Mars if there's life on Mars?
Yeah.
What happens next?
That's a great question. I do know NASA now has a planetary protections, people that's their job to think about those questions. Some of these meetings I've been to, there have been people that have expressed their concern about that. They're like, you know, even these sample tubes that we're bringing back, are we doing everything in our power to make sure that we're not accidentally, you know, hitching something back to Earth that it's going to cause, you know, the next pandemic or something like that? So I do know they're undergoing a lot of tests before we handle anything that comes from these sample tubes. A lot of planned analyses will actually be done without even removing the tubes from the sample. But what then will that allow humans? I can only have conjecture with this, but I imagine that, if we find something that's fossil, that'll be a different story than if we accidentally find something that's living and microbial. That would be a whole other story, and probably have to, get the microbiologist to run some tests on that. Whether and then determine if this is something that's a problem for humans, or if that would influence us being able to one day go to Mars or anything like that. I can tell you this is other people's jobs, and I don't know what the current consensus is on that, but we won't know unless we look for it.
Well, the thing is, once humans go to Mars, there's going to be human microbes or Earth microbes on Mars.
You're exactly right. Yeah. Yeah, I think the estimate is, with the gravity and the dust storms on Mars, it would be within 2 weeks of humans landing there, the entire planet would be contaminated, is what I've heard before. So it's one of those things where the Perseverance rover also kind of allows us to get there and do some of this stuff before humans. And depending on how optimistic you are, you might think humans are going to be there in the next 20 years, or some people are less optimistic than that, but who knows?
Well, then you also got the problem of these are NASA's protocols. You've got a bunch of other countries that can send probes too, and they may or may not clean their probes as well.
Yeah, and the other thing too is, it's not even limited to other countries' space agencies now. Now you've got your private companies that can do this. There's really, what is there to be stopping someone like Elon Musk from making his own Mars mission or something like that? And I know that's a topic of debate, and I know even some folks within NASA themselves disagree on, let them trailblaze versus, no, they need to sit back and let the experts get in there first type of thing. So yeah, it's hard to say.
So there's a couple of questions and comments from the chat. We have Alan and Cheryl say wonderful talk. So
thank you.
Bill Sojeris, great topic. Thanks. So a couple of members really do enjoy the talk. Chris Rizzo asks, how can photosynthesis occur without chlorophyll in hot springs?
Gotcha. This is one of the reasons why I team up with microbiologists when I do my research out there, so I can defer these hard-hitting questions on that to those folks. But they're discovering all the time that life in hot springs is much more complex than we once thought. I mean, the same is true for microbiology anywhere, but there's even evidence of some microorganisms that can switch between doing photosynthetic metabolisms to chemosynthetic metabolisms and back and forth. So we do have evidence of, especially on Earth, we know these are happening. Photosynthesis is happening in hot springs. And actually, some of the oldest evidence of life that we have on Earth comes from something called a stromatolite, which is little triangular structures that you can see, or sometimes domal structures where they're curved upwards because it's the hypothesis is that bacteria or microorganisms in general that were living inside of them are using something called phototaxis to climb up towards the sunlight. So exactly how the metabolisms work in any given hot spring on Earth, much less Mars, is still something that's being investigated. I mean, I can tell you from my own research, even something like investigating why am I seeing these trace elements in the fossils. It's, for instance, if I saw a concentration of arsenic, which I did see sometimes, is that because they're using arsenic in a beneficial way? Probably not. But we do know of some microorganisms that take in a harmful form of arsenic and then reprecipitate out a less harmful form of arsenic. some organisms might scavenge for iron using something called siderophores and unintentionally bring back other elements like gallium that they then don't want and essentially spit back out. So it's still pretty confusing, the exact metabolisms that's going on there, but you know, I can send you a lot of papers on that too if you want to have your reading set for the next year.
All right. Ken Burton shares great talk.
Thank you. Oh yeah, thanks for the link too, Bob. It's from Adelites there.
Yep. And I posted that to our the few that are watching the YouTube stream that we're doing. So
yeah, thanks.
So
I see Gerald has a question there.
All right. Gerald, go ahead.
Oh, still muted.
Yeah, there.
There you go.
There was a meteorite that came from Mars, was found in Antarctica, I believe, several years ago. And they thought they found microorganisms in that, but it was controversial. What's your opinion about that?
Yeah, that's
Are you familiar with it?
Yeah, it's the Allen Hills meteorite, ALH,
yes.
and it was actually I think Bill Clinton actually did a press conference, a very sensationalized press conference when they found that thing, you know, evidence of life, which is, I remember reading in a book about that where it was my PhD advisor's advisor was the one who kind of got to look into that and see if there's anything legit for it. It looked, if anyone has seen pictures, yeah, Bob posted it in the chat there. There is a little structure that looks like essentially what I showed you tonight. It looks like a filament. And what was conveniently left off of most of the pictures that were shared of it was a scale bar. It's nanometers instead of micrometers, like the stuff I was showing you. So it did not fit a conventional size range for what we would expect life to be. And I believe, you know, last I checked about this, the two prevailing opinions was it was either something inorganic, or you know, something that was non-living, or actually an artifact from how they coded like the actual meteorite to take that super zoomed in image. You can get those. People have reproduced how you can get that type of structure artificially. So it's been used in astrobiology classes, and papers have cited this as almost like a cautionary tale of like, you know, this is why you need multiple lines of evidence. And yeah, there's even a recent paper that came out on exactly what you're asking about. So, but it got people interested, you know. So if nothing else, it showed that people care about life on Mars, even if it is a, you know, little tiny microorganism.
Would organisms be affected at all by gravity itself as far as their size or their ability to grow?
Yeah, I mean, we have basically, you know, we've got everything here on Earth. You know, that's one of the main reasons we think, like, okay, and this is a subjective thing, but the prevailing opinion that I've heard thus far is we think if life ever did arise on Mars, that it would still be there because it's really easy to kill off 99.999% of life, but it's really hard to kill off 100% of life. And we have evidence of life on Earth that lives deep in the subsurface where they're exposed to, you know, higher heat, higher pressure, you name it, you know, high radiation, where we still think there's some constraints. You were asking about gravity and size. There's still some constraints as to just, you know, with basic chemistry and water and how the minimum size something needs to be. But interestingly enough, if you look at some of the proposed earliest evidence for fossils on Earth, a lot of the fossils that are microbial are like millimeter sized. So they're huge by, you know, microbial standards. And we think that's because, you know, they could occupy a lot larger niches because, you know, nowadays they'd be kind of outcompeted by larger organisms, even something like a protist. So they could potentially be, you know, there's nothing necessarily stopping something from being a lot larger. You do start getting into some, you know, chemistry problems with capillary action and stuff like that if it gets too small. But just from how we think life would have evolved, it would have started at a single cell, just because single cell is easier than you know, something that's multi-celled and, you know, has a nucleus per se, eukaryotic. But so because of that, they would probably be pretty small and pretty simple, but you know, that size range could vary widely. I don't know exactly how much specifically gravity would influence that, but yeah, it's an interesting question.
I'm looking at this website about the Allen Hills meteor. It was found in '84, and the announcement in '96 is when they thought they found something. That was well over 2 decades ago, and I have not heard of any Mars meteorite. Now, people gotta be doing research on them in the last 2.5 decades. I have not heard another announcement to that effect.
Yep, there's really not been anything since then. This was pretty early dismissed by a lot of experts in the field when that came back. You know, it got sensationalized a little bit, but we have yet to find something else in that same category. Every now and then you can see, if you ever look up, like, people have tried to Photoshop color a rock formation on Mars to say it looks like a bear or a frog or something like that, but that's the only thing I've heard of that's been convincing evidence, you know, quote unquote convincing evidence of life on Mars there.
So, any predictions on when we're gonna find life? If not on Mars, anywhere? Not even gonna go there.
I mean, it's a good question. I personally think even if we did find something super convincing from the Perseverance rover, and, like, you know, when I've been doing uh, my own geology field works and stuff like that, very often I'll collect a bunch of rocks from around the same area, and for whatever reason, not all of them have fossils in them. Only one of them does, and it's only in one part of it. So, like, if we're bringing back cores that are pinky sized, I think it's, you know, it's possible we miss. It's likely, I think, we miss something that's going to be a slam dunk. So even if we did happen to find something, I think there'd still be a lot of skeptics of really announcing one way or another that we found convincing evidence. I think we'll have to go back as humans where we can get that replica, get a whole bunch of other samples. 'Cause that's, you know, that's what you have to do for any good science, is replicate your results. And because we're trying to get a diverse sample set from Mars, you know, we're going to get couple pinky sized samples from all over the place, and, you know, a lot of them will be sample size of one, and that's all we'll have. So, you know, it's impossible to know one way or the other, but I think we might have to get boots on the ground on Mars to really answer that one way or the other.
From YouTube, Victor Valentino chimes in, the geology can be so interesting, especially the fossils you find in the geological record. And I'm assuming you might agree with that a little bit.
I would, yeah. It's really interesting when you get back to this stuff from the Precambrian, you know, the 3.5 billion year old fossils and stuff like that, where it's, I mean, again, like I said, there were papers that were coming out when I was born, before I was born, and arguing, and the folks are still arguing, and a lot of these arguments go on until somebody either retires or dies, and that's just, you know, sometimes it's, you know, the evidence is not really, there's not that much of it, so we have what we have. The saying goes, the older the rock, the greater the chance it no longer exists, and stuff tends to be in pretty bad shape when it's been around for a few billion years. So it's perhaps not terribly surprising that a lot of this oldest evidence wouldn't be cut and dry, clear evidence, but it certainly, hey, it gives us something to do.
Yeah, and that actually generated a question for me I know there's the scientific method, the scientific process, but I think more and more these days, a lot of opinion or, things are might be creeping in. How easy is it to keep things on a strictly scientific level when it comes to looking for life and to, as opposed to conjecture and, even though I would, I say that I'm religious, I know there are certain things that you try and keep some of it out and get objective when you're looking for objective data to say scientifically that you found life. How
Right.
how does that work?
Yeah, I mean, it's a great question because, it's like one field that a lot of my colleagues deal heavily with is origin of life. So how did life arise on Earth? And like, even if there was, we don't have rocks that would have preserved that. They've all been destroyed from that amount of time, probably. So a lot of those fields have shifted from, there's a difference between pure conjecture versus conjecture, a hypothesis that you've formed based on laboratory recreation. So like the paper that I mentioned from my colleague Bruce Damer and David Deemer out at UC Santa Cruz, they published that they thought terrestrial hot springs like Yellowstone is where life would have originated. But they didn't just say that based on nothing. They had essentially recreated early prebiotic chemistry environments of these hot springs in their labs, and the experiments worked. They were able to form what they called these protocells and like get them to complexify by simulating an early Earth environment. So there's conjecture and there's conjecture. It does get interesting, from an anecdotal standpoint. When I'm doing outreach events or something like that, I always talk about astrobiology and searching for aliens, and it gets the kids really excited. And then when I say, well, microbes on Mars, people get less excited. It's like, oh, I thought you were talking about, ET stuff and, intelligent life. And
Right.
the interesting thing is we are doing that on Earth. Organizations like SETI are looking for signs of intelligent life elsewhere out there in the universe. Like these are things that are happening. And when you look at the sheer size of the universe, it's not unreasonable to think that other intelligent life could be out there. And to address your last comment on, the religious aspect of things, that's always an interesting question. I always defer to, the Big Bang was first proposed by Father George Lemaitre, who was a Jesuit priest. One of
Right.
our adjunct curators here is Guy Consolmagno. I'm not sure if I'm
Yep.
butchering any of these
We know.
names.
Yep.
Yeah,
He's
Vatican
given it.
Observatory. So some
Yes.
people, don't have a problem with making that step of, even if you want to say God did it, they say God did it, but the Big Bang was the way that it happened, through that. So, and when
Yeah.
it comes to that, that's outside of my pay scale to address those comments. So
No, completely understandable, and that's
yeah,
the line that we toe. I'm
exactly.
also Catholic, and
Mhm.
separating the faith from the science is something that we always grapple with because we want to reach everybody when it comes to all aspects of space and science, and in order to do that, me personally, I feel we have to sometimes relax some of the hard religious charge and the hard science charge has always been at odds.
Right.
So just looking at evidence and agreeing to looking at evidence using the scientific method, starting there.
Yep.
I know the church has said if evidence of life is found and agreed and peer reviewed by other scientists and ratified and everything else, then the church may come with a statement, and and the theologists might jump in, and we know everyone's going to have an opinion on social media, so
Right.
that would
Yep.
be coming. So
Yeah. And
but yeah, until the meantime, I know the Catholic Church is trying to stay out of conjecture and let the science do its thing, and
right.
and we'll wait.
One other
Sherry
quick
had a
comment.
question.
Oh, sure.
Yeah, go ahead, Jer.
Yeah, I have a question. Are you aware that we have in Michigan some of the oldest rocks that are Precambrian in the Upper Peninsula? And
Yes,
have
right.
you studied those, and have you any plans to make like a field trip up there?
Oh yeah, I'm waiting. But yeah, so right up at the Canadian Shield,
Yes.
some of the best, most famous microfossil locality, maybe in the world, it's called the Gunflint Formation. Right between, Michigan and Canada up there by Alpena. And that was the widely regarded as the most convincing microfossil evidence, because not only did it have exquisitely preserved microfossils, but it had a bunch of several different size, shape, morphology microfossils. So there's essentially no chance that all of those different microbe-looking things could have existed in the same rock, without the answer being it was because there were, living organisms. So I have some samples that I've actually already collected from other people just giving me the samples, but I'm really excited to make my way up there.
Well, Alpena is still in a lower peninsula, but if you go
Right,
up
yes.
further across the bridge, there's rocks that are so old they don't have fossils. They're
Yes, and
Precambrian.
yes, and those are, where I'm less likely to spend my time, just because they're
Well,
so altered.
if
Yeah,
if you start at the bottom and work up a little bit, you're going to get into fossils, and those are the earliest
exactly,
ones.
exactly. Yep.
So,
Exactly.
Gerald, you also just gave me more targets for my travels for
That's right.
nightscapes, let alone the search for ancient rocks. So thank you for that. Now I got to put it
It's
on my list.
it's pretty dark in parts of the UP where there's just woods and no people.
That's
Love it up there.
Yeah.
that's what I look for. That's when, so Bortle, little quick thing, Bortle 2 Sky, when you cross the bridge and you go about 45 minutes, you begin to enter the Bortle 2 Sky. I stopped my truck and looked around. There's nothing but, kind of a flat area. And I looked up, and that was the first time I saw structure and color in the Milky Way. And I took some pictures, it blew me away. So, not to detract from the ancient rocks that are also there, which, topic of the talk, but yeah, the skies are beautiful
Yep.
in that
Yes.
area.
And
Yes.
Thunder Bay is the place where you find those Gunflint locations. So it's just, it's still Lake Superior, but just past the Canadian border, if you're looking for a good spot to go.
Okay, we're coming up at 9:30, which is generally when we shut down, is it not? Anybody else have a final question for Andrew?
If so, you can always email me afterwards. I think, you've got my email on file there, so feel free.
Okay, well, with that, thank you very much for the presentation.
Yeah, thank you. I appreciate it.
Thank
Thanks
you
for
very
having me,
much.
everyone. I had a great time.
Appreciate it.
Yeah, thanks for your questions as well.
And with that, we're going to close this meeting down. Have a good evening,
Great.
everyone.
Have a good night, everyone. Thank
Good
you.
night.
Good night.